So chemical formulas, how do we represent compounds? The reason that the compounds have constant composition has to do with the atoms. Atoms of a given element have the same mass, or very, very close to it. And so the reason the mass ratios are the same is because the ratios of the numbers of atoms of each element are the same. So we use chemical formulas to indicate, so chemical formula is going to show us the elements that are in the compound and the relative numbers of atoms of each of them. We're going to use subscripts. And again, we're going to avoid the number 1. So how does this work? Well, sodium chloride. This is the chemical formula for table salt. And we've got Na with no subscript and Cl with no subscript. That tells us that there's 1 sodium for every 1 chlorine. If it was 0 sodiums, we wouldn't write sodium, the Na at all. If it was 2 or 5 or 17 sodiums, we'd write a number. So when there's no number, we understand it to be 1. There's CO2. CO2. 2 oxygens for 1 carbon. This is the formula for table sugar, sucrose. C12H22O11. That one's a lot bigger, isn't it? But this is the lowest ratio. C12H22O11. So there's 12 carbons for every 22 hydrogens for every 11 oxygens. And that's what a chemical formula means. The subscripts are an essential part of the chemical formula. If you change the subscript, you're changing the formula, and you're also going to change the properties of it. So examples here are 2 different compounds formed between carbon and oxygen. The first one, CO, has 1 carbon and 1 oxygen. This has the name carbon monoxide. Carbon monoxide is an air pollutant, and it's toxic. If you have a gas heater or a gas refrigerator or anything that's not vented properly, that's not getting enough oxygen, it will give off carbon monoxide, which is very toxic. Carbon dioxide is also between carbon and oxygen, but now the ratio is different. Carbon monoxide always has a 1-to-1 ratio. Carbon dioxide is always a 1-to-2 ratio of carbon atoms to oxygen atoms. 1 carbon to 2 oxygens. Carbon dioxide. This is relatively harmless. When you breathe out, you exhale carbon dioxide. So this whole time we've been in lecture, we've all been making carbon dioxide and spewing it into the air. Is it hurting us? No. Of course, way too much of it would hurt you, but way too much of anything would hurt you. How do we know which element to list first? Well, let's look at some examples here. Why do we write NaCl and not ClNa? This would be alphabetical. Why not do it that way? It's just convention. So the more scientific explanation is that we list the metallic element first. So we'll list the metallic element first. If there is no metal, then we're going to list the one that's more metal-like first. So I tend to think of the metals as being masculine. This is in my, funky chemistry world. Metal, those are masculine. And the nonmetals then would be feminine or not masculine, right? So they're kind of opposites, and yet they're not, just like men and women. Feminine. Yeah, I think that's right. So when you're addressing a formal invitation, do you write Mr. and Mrs. or Mrs. and Mr.? It's always Mr. and Mrs. Why? Because that's how everybody does it, right? So we are familiar with rules like this, where it's just somebody sometime decided to do it that way and everybody else, we're just all doing it the same way. So that's how it is with which element goes first in the formula. It's the one that's more metallic. So in this example, sodium is the metal, so sodium goes first. In this example, we have nitrogen and oxygen. Neither one of those is a metal. But on the periodic table, nitrogen is to the left of oxygen, and the metals are over on this side. Nitrogen is closer to the metals than oxygen is, and so we're going to list nitrogen first and then oxygen. This is not a big deal, but there are always students who are curious and they wonder, why? Is there a rule? How do we know which one goes first? This is how you know. So I think that general rule, the more metallic one goes first, works most of the time. Here is a more specific listing for the nonmetal elements about which one goes first. And we're not going to get too hung up on that. Well, let's do this example. Write the chemical formula for each compound. So compound containing 2 silver atoms to every sulfur atom. So we've got silver and we've got sulfur. Which should we list first in the formula? The silver, because silver is a metal. What's the symbol for silver? Ag. Okay, so you had a list of things to memorize at the beginning of the semester. I am assuming, perhaps incorrectly, that you still have those things memorized. So silver, and it says 2 silver atoms. So we're going to put a subscript 2 after the silver. And then the symbol for sulfur is a capital S. And it says there's one of them, so we're not going to write a number 1. So a compound containing 2 silver atoms to every sulfur atom would be Ag2S. Let's look at nitrogen and oxygen. Okay, we were just talking about nitrogen and oxygen. They're both nonmetals. But the nitrogen is closer to the metal side of the periodic table, so we're going to list the nitrogen first. This is 2 nitrogen atoms, so N2O. And we want to make sure that our capital letters are capital sized, because some of them, it can make a big difference. Like CO is carbon monoxide and C(o) is cobalt. There's a big difference there. So make sure your letters are the right sizes. How about a compound containing 2 iron atoms to every 3 oxygen atoms? Fe2O3. We're going to list the iron first because it's a metal, the oxygen second because that's the nonmetal. And the iron gets a subscript 2 because there's 2 irons, and there's for every 3 oxygens. Any questions? And that's where I left off with the Tulare people.